This talk with this very long title, it's really about a visual query system. That's the name of this this whole research field. Going back to Jeff Hare's talk, you talked about sort of lifting a domain-specific language up into an actual user interface, and the domain-specific language in this question, in this case, it's SQL or SQL-92. You know, the core of SQL. I'm actually going to show you a tool that lifts all of SQL-92 into an actual direct manipulation user interface. That's kind of the holy grail of this visual query system research field. There has been hundreds of papers written on this topic. So the main challenge academically is to show you why is this system new? What is it that I've done here in this system that's not been done before? And so very neatly, there was a paper written by Liu and Jagadish a couple of years ago where they set out a couple of requirements for a real graphical replacement for SQL. And I put up these requirements here. The first is this requirement of direct manipulation, that old user interface term for things like spreadsheets and word processors and user interfaces where you really get to work directly with whatever it is that you're trying to produce. So in this case, a tool like Tableau or Excel, you're directly manipulating some data on the screen in order to do some sort of a class of database queries. So that's going to be our first requirement, being able to construct database queries by actually touching the data, doing operations on the data itself. Now, the second requirement is related to direct manipulation. So this is a little more subtle. So suppose you have a tool that actually lets you construct database queries by just touching the data, clicking on columns, saying filter, saying sort. Now, in Wrangler, Trifacta, for instance, you'll see this script being built on the left-hand side of the screen. It's like you're building a sequence of operations. Now, the second requirement here is actually if you want to modify a query that you've constructed, you should still be able to do those modifications by direct manipulation. So if I set a filter and then I do some aggregation, I hide some columns, I should be able to set that filter that I set 20 steps ago and change that without having to edit some sort of script or something outside of the direct manipulation interface. So then there is the third requirement is we want to be able to actually construct arbitrary SQL queries. So if you look at all the related work, you'll find that every previous system has failed in at least one of these three requirements. It turns out to be very hard to achieve them all at the same time. So I'm going to show you the first system that actually achieves all of these three. So the key insight that we're going to use here is, I think it was also Jeff here that talked about the input and the output domain being the same in the case of autocomplete. In this case, we're going to do the same thing. We're going to have a single user interface, a single visualization on the screen that shows you not only some data from the database, but that simultaneously shows you the query that was used to fetch that data. That's tricky because we're doing arbitrary SQL queries here. SQL queries can be nested. You can have averages of sums with a filter being done on the result of that first sum, etc. So we're actually not going to restrict ourselves to just showing tables of data. We're going to show something called nested relational data. And you'll see that in the user interface. This is what the user interface looks like. You're always going to be looking at a selection of data from the database. There's something subtle about the way we visualize this data. This is what we call a nested table, or a nested relational data layout. We're actually able to show here in a single sort of tabular representation, we're able to show one-to-many relationships. One-to-many relationships in the data, one-to-many relationships in the query. So we have the courses Roman art and comedy here that each have a reading list. And independent of the reading list, they have sections, lectures, precepts, etc. So every operation you're going to do in this tool, it's going to start by clicking on one of the fields in this result, in this output from the query. You're going to do spreadsheet-like operations like sorting, filtering, etc., but also a couple of other things, like you're able to show fields that you might not be displaying on the screen at the moment, but that you might have available from other tables in the database, or from the same table that you're currently looking at, but you have some hidden fields and so on. And you have the standard sort of Excel filter. But that is pretty much the interface. And the neat thing is that just given these operations, there's a few of them here, but just given this set of operations, you can actually express any SQL-92 query. I'm going to give you a demo of this. I'm going to just go through the basic operations of this system and talk a little bit about each one of them, and then we'll see how they can all be used to actually create some quite complex queries. So I'm going to show you a video here. This is real time in the sense that it's not sped up. I recorded it just so I can annotate a little bit. A query building system in this tool starts usually by selecting a table from the database. This is like a course catalog database. So you select the table of courses, and now we're in this direct manipulation interface. So here, the first thing I'm going to do is I'm just going to select a couple of primitive fields from this table. Nothing too exciting yet. I'm just showing a simple, select from this table of courses, a simple SQL query. Now the next thing I can do is I can actually do a join against another table in the database. So there's a table called readings, and I'm going to be joining that in to the courses table in order to show for each course all of the readings in the reading list. So these particular joins that I did right now, they are equijoins over foreign key relationships that are declared in the database. Very common, not a requirement, but this is a very simple kind of join to do in the system. I've just shown some columns from a related table in the database. And you have little icons here that give you some hint of what's going on in the query, and you can see the details in the menu that you can open up to select fields and so on. So I'm now showing just a simple join equijoin between two tables in the database, and I can go and I can show a few more of those. I'm just going to select fields from other tables in the database related through foreign key relationships, and just show you how powerful this kind of visualization is. So right now, I'm just hiding a couple of fields that I don't know, but right now I've shown you essentially a course catalog. I've shown you for each course the area of that course, like literature and the arts, and I've shown you the reading list like we saw before, and I've shown you the section list. And for each section, there are meetings. So this is a way to show all the one-to-many relationships that come from these different joins. And there's indications here, icons showing you where exactly there are one-to-many relationships. This is a kind of view that you will not be able to produce in most standard BI tools, like Tableau, for instance. You will not be able to construct this kind of visualization in a tool like Tableau. This actually is a little more subtle. The next thing we can do, I'm going to hide some fields just to make the example a little bigger. Next basic operation we can do is we can do some sorting. So here we're sorting the reading list on the author name and then by the title. And then at the outer level, the course level, I'm sorting the courses on their maximum enrollment. So now we're seeing the courses with the lowest value for maximum enrollment first. The reading list of each course is independently sorting. That's how sorting works in the context of this nested relational view. Next thing I can do is to do some filtering. I can filter on any column. In this case, I'm filtering to show only courses for which there is a meeting on a Wednesday. So we've seen that here. We get a little icon where we have added that state. There's always a way to get back and open back up again that filter and actually change it again, and always an icon to remind us where there is state that we might need to change again in the future. There's also a question with nested filters like this of what level do you want to filter on. So in this case, I'm showing one of the other basic operations, which is to show, in this case, I modified the query a little bit to say, show me all the courses, whether or not they have any meetings on Wednesdays, but then in the section list for that course, only show me the Wednesday sections. So that's a little bit of the nuances of the filter operation. The next thing I can do, just cleaning up this query a little bit for the next example, we want to model all of SQL 92. One of the basic operations you can do in SQL, and something that's actually very useful, is to be able to do calculations. And you can do that in the system. The way that's going to work is we have a feature called calculated fields, something you will hear in many BI tools. It's essentially Excel formulas. That's what we want it to feel like. I've added another column here that has a little formula icon. I'm going to call it whatever I want, duration, and I enter a formula just like in Excel. And I'm going to do just calculate the number of minutes of each meeting. So I entered one formula that applies to the entire column, unlike in Excel, and I automatically get for each meeting the duration of that meeting. That's because I put the formula at the level of each meeting. I can also do an aggregate function. So suppose I want to now total up the amount of time for each section. In total, I can put another formula in the same way out here at the courses level, and I can do a sum, like in Excel, but again, not quite like Excel, because we're now actually in these formulas referencing entire columns of data rather than just individual, specific ranges of cells. This is a good thing. Let's just rerun the query for a future version of the data and get valid results. So I enter this formula. The system figured out that because I put the formula at the level of each course, it's going to group by courses when it translates this to SQL. I can call this whatever I want, total duration, something like that. Aggregate functions, filters, they interact. If I filter on a particular kind of section, for instance, I'm going to get the total for just those sections. So here we are seeing we are filtering on precepts only, excluding lectures, and getting only the totals for precepts. There's a couple more features that you need in order to be able to model arbitrary SQL queries. Here we're just preparing this example a little bit again. There is a feature called hide duplicate rows. This is essentially equivalent to your select distinct in SQL. There are also ways to get regular flat joins. So I showed you one kind of join, the standard way of doing joins in the system, where you see actually nested joins. There's also a way to get your plain old inner joins like in SQL. You can do that with the formula. And now I've shown you a ton of different features in the system, but on the other hand, it took me probably 7 minutes to show you this, and that's it. These are the basic features that you need in order to model all of SQL, or SQL 92 specifically. So to recap this, I've shown you a user interface that shows you in a single user interface on the screen at the same time. We've shown you a representation of a database query together with the data that is retrieved by that database query. So now we have a complete direct manipulation interface for actually creating and modifying queries. So you'll have to go to the actual paper to see how can you do arbitrary SQL-92 operations. You need to go to the relational algebra, figure out which operators are needed for SQL-92. That's actually very hard to find a reference for, but I have talked to people who have actually implemented a relational database and claimed SQL-92 compliance, and you basically need relational completeness plus a few more operators. And if you can manage to prove that your system can express all of those different operators, then you've covered SQL-92. Evaluation, we did a couple of user studies. One sort of open-ended formative study with a couple of tasks that we have prepared in addition to some more explorative tasks. We also did a controlled study. Wanted to do it against Tableau. Turns out they have a Duvet clause in their license, so you're not actually allowed to publish any performance results if you do studies with Tableau. But we did it with Microsoft Access 2016 because Access has a query builder. It's not quite as powerful as this one or expressive as this one, but having users do tasks in Microsoft Access 2016 and this tool. You can actually ask them how usable they define the system. There's a standardized scale, the System Usability Scale, that can be used for that. Basically, what you find is that our system, in terms of usability, it's just right on average in terms of other business software. Microsoft Access, it's in the bottom 4th percentile. So it's basically, we've taken database querying from something that is completely unusable in Microsoft Access 2016 to something that is reasonably usable even with a research prototype system. Conclusion, these are some quotes from our users that tried this system. I just feel like I have a truer sense of what I'm adding up. In Excel, you could be pulling from the wrong places. You can be getting weird numbers. You could accidentally hit a field that now ends up in your calculation. This relates to how formulas work, etc. Took me a lot longer to get anything useful out of Access, etc. So, in conclusion, we have a system that can actually let even non-programmers do arbitrary SQL queries without actually having to learn SQL. Thank you.
Thank you. Thank you.
Seems great. Is there any demo version to play with?
Not quite yet. If you actually email me, you can get a very, very pre-alpha version. But I'm planning on spending the next year on polishing this up into something that can actually be used. So, soon.
Any other question? Okay, well, maybe I have one question. So, so you did user study to compare like your tool against the other Access in general. So, what do you think your tool would be best for in terms of the users, like which demographics that you expect? Would they be data scientists? Would they be students? Or would they be people who are learning?
Yeah, so there's two classes of people. I think the first is people in other professions that see us that might be very comfortable with Microsoft Excel, and they're maybe contemplating learning SQL, but they don't have the time. So you can find investigative journalists, you can find lawyers, etc., business intelligence people. But in fact, even computer scientists, even programmers who have a relational database that maybe they're developing on or they have access to it from other reasons, this tool is actually quite a lot easier to use to explore data in your database than actually typing out SQL queries yourself. There's a lot of stuff done for you here that you don't get when you're typing SQL. So for instance, if you're doing complicated aggregate queries here, you can actually see what goes into these aggregates. You can see, if you have an outlier like Jeff's null example, you will see that in the tool because of the way we have to visualize the data and the entire query.
Okay. So, thanks a lot.
Thank you.
Let's thank Eirik again. Thanks.